So, a small self-introduction. Say I have 8 years of experience in teaching and 6 years in interior design and 4 years with SIFI as a head taking of design. So I trained more than 2,000 students and 3 lakh square feet of functional interior design. And also our team won a 4 Brandon All Award for our product solution in SIFI technologies. The reason why I kept this slide is about 3D modeling. So once while I joined CAD Center, the 3D modeling is something used for a presentation. Say I usually handle students in mechanical, architectural, and civil oriented people, and they use 3D software as a presentation software. Say they create a model, they bring it in 3ds max and do some texturing or animation and take it as a demo reel. So this is what actually they do in 3ds max. Later I joined Maya Academy of Animation and Cinematics and SAE and then Image Infotainment. Here I learned 3D modeling is something different, like what to say, like it is used for the visual effects, it is used for the animation industry, it's used in a variety of field. Then I moved to interior design, where everything is a practical interior. The 3D model is something actually used for presentation, where it's an exact representation of a CAD drawings. Then when I moved to SIFI, the entire scope is changed. I'm taking care of VR, AR, where I need to create a low polygon model. So previously, when I worked in VFX or animation, I never thought about the polygon amount, budgeting, and all things. So we do anything and we create a visual representation and we present. But when I come to SIFI, there is a restriction. Say polygons are need to be less. For example, a complete machine, a machine comes around 20,000, 30,000 polygon has to come in 2,000 polygons for better performance. So this 3D model vary from field to field. When it comes to animation, it is different. When it is come to AR and VR, it is different. What is this 3D model? Basically, the 3D model is a mathematical representation of an object. So I'm just going to show you a small example. So it's taking some time to load. So I'm using a software called 3ds Max for my 3D modeling software. It's take a while to load. Yeah. Actually, I have a very few slides. I'm going to talk about 3D modeling, the process involved in 3D modeling, and various techniques used in the 3D modeling, like eye detailed modeling or a low polygon modeling, the workflow of eye to low. And also, I'm planning to show you something called a substance painter, and there is substance alchemist, which is a product from Adobe. Now, previously, it is an algorithmic product, so used for the texturing and detailing purpose. And also, I'm going to talk about a little about ZBrush. So, how we do projects for various client. So here I'm just creating a plane. Actually, it is a representation of a 2D. Usually we use a Photoshop or a Flash. It's a 2D software where we usually animate the pixels or the utilizing the 2D space. That is the length and the width. But a 3D model is something where it is a representation, mathematical representation of an 3D object. For example, if I take this box, I'm going for a wireframe. It's have actually 8 corners. When we are talking about a 2D image, it is all about pixels. Every pixels stores some value. So based on your pixels and color information, the image size varies. But in vector based, you may hear about the raster and the vector based. So here the 3D models are made up of vector. So every point here, all these 8 corners have a coordinates, x, y, and z value. So you can see there is an x direction, y direction, and the z direction. It's represent the length, breadth, and the height. So even when I try to draw a box, you can see length, width, and the height. So here, this is the length and the width. You can see the value here. Length and width is changing. Then I'm creating the height value. So all this length, width, and height is represented in x, y, and z. So every point have some value. See here, the bottom part, you can see the coordinate systems. We call this as a universal coordinate system. So this coordinate systems contain the value of this particular point. So when what happened when I zoom in, actually the 3D engine in 3ds Max takes the nearest points of the 2 coordinate system and redraw this line every time when I zoom. So it is more accurate comparing to the pixel based 2D animation based softwares. So here I can create any object in a 3D space, and you can, when I'm selecting the second point, you can see the values are changing. Third point, here the y value is changing. Here also it is a 29 minus 29, and here it is a positive 29.461. This is the value of the actual box. So this way I can create any object. So I'm just importing a model which we use in our project. It's a complex mesh. We created a 3D character with all the lights and the bone system. So here is the bone system. creating this mesh is part of our job. Like we create the mesh based on the flow, the eye, the ears, where it has to connect, and each point carries the value. So more points your system is getting, evaluating the more values. For example, every time when I rotate this object, it will take all the XYZ points and transform that object. Now I'm actually viewing this object, so nothing will happen. In case if I try to move this object, the 3D engine behind the scene, it's actually calculate where this point 1 move in the XYZ from value to a to value. So it is a CPU intensive work. So lower the mesh, the performance is higher. And actually here I have other models. See, I have a low polygon model. It is a list of model present in the scene. Lights and all the details. I'll show you. See, I have a multiple objects present in this area. The reason why I created the multiple objects is we call this as a LOD. That is a level of details. For a longer shot, we use a low resolution mesh. For a medium shot, we use a medium res, and for a close-up shot, we have a detailed mesh. So we usually create assets using a CAD software or a DCC tools. CAD software is nothing but computer-aided design like AutoCAD and other softwares. DCC or digital content creation tools. And these techniques actually using two types of modeling technique called solid modeling and the surface modeling. So solid modeling, the actual model is solid. You cannot keep one object to another object. Example, like a sphere and a box, you cannot keep it inside because it is a solid. Either you have to curve it in a real-time example, when you are taking a ball bearing and you want to infuse a small square, then you have to remove that area and you have to integrate this as a one single object. Some examples of solid modeling are Pro-E, SolidWorks, AutoCAD, Creo, or Fusion 360. Mostly used by the engineers. And surface modeling or like a paper. It is like a balloon where you can keep another object inside a balloon. So some of the softwares are Blender, 3ds Max, Maya, Modo, Cinema 4D, ZBrush, and other softwares. The reason I use 3ds Max is from 2000. I started using 3ds Max at the time. 3ds Max is very famous. So I learned 3ds Max and I'm comfortable in 3ds Max. Blender is also another tool. It is an open source tool. Maya is a competitor actually for 3ds Max. Maya like exercise, soft image exercise. But later Autodesk acquired Maya soft image. And now it is a product called Autodesk 3ds Max, Autodesk Maya. And also we have softwares like Modo, Cinema 4D, and Pixologic ZBrush. Even though there are so many softwares, the process is same. Like how the sculpture doing the sculpting a stone, the same way the tools are basics. The user interface may vary, but techniques what they use is same. Why we use 3ds Max or Maya is the pipeline is the integrated pipeline is so comfortable for us. For example, we have a motion builder, Autodesk Motion Builder, Autodesk Maya, and also Autodesk Mudbox. All the softwares are from Autodesk. So creating a model in 3ds Max and transforming it or transferring the model to Maya or a motion builder or a Mudbox is easier. But when we are using a Blender or a 3ds Max, the pipeline is little complicated. So that is the reason why we use 3ds Max for our presentation. The 3D modeling process is something where we create a 3D model. Usually we do animation, maybe a camera animation or a character animation called as transformation. We move characters from one place to another place. We rotate or we scale down an object. That is called transformation. Or else we do a bone animation. So I shown you a character. Like how we have a bone system, the same way we create a bone system and we try to move the bone and to do the animation. The next is called as a texturing or material authoring. So even your model have a artifact that will be rectified using the texturing process. It is like giving a skin color or a glass or a dress. So whatever you want, you can externally you can apply. That is comes under the texturing. The final one is the lighting. So you have to illuminate your object properly, and then it goes for the rendering, the final rendering or an exporting process. In case it is a video, we do the rendering. In case it is a game or other industries like AR, VR, we export the model. So we see this in details. When we are talking about 3D model, 3D model used in various areas like animated movies, visual effects, motion graphics, games, AR, VR, or MR. So what is the difference? How it differ? So I'm going to show you some simple examples. When we are talking about the motion graphics, this is some showreel of motion graphics artist. So it is a completely a 3D one. Most of the music videos or previously we call as MTV and all uses this type of technique. Nowadays, like Adidas and Nike uses this technique to advertise their products. So I think it is playing bit slower while reading. You can see a lot of this example in YouTube. These are like liquid simulations, lighting effects. It all comes under motion graphics. And also animation. My favorite is Pixar Studio. And this is a small short film. I'll explain you what is the process involved in animation and AR VR. First, we'll see to this small clip. A very small scene. Slowly, it is getting dramatic. You can search in YouTube for as a Pixar. You will find so many videos. You can see the expression of those birds. So all the feathers are gone. So some of the Pixar shorts are Oscar award for the short film category, animated short film category. So this is animation and motion graphics. And I'm going to talk about the VFX. I have the Pirates of the Caribbean from Digital Domain. Digital Domain is a VFX studio which created a lot of sequence for Pirates of the Caribbean. So actually they did a color correction. And some of the scenes are created in graphics. So this is not a real ship. Actually, they use a blue background, and these are all composited. The smoke, the particles. Here is walking. Actually, he is walking a blue background, and all this demolition is happened in the 3D software. So they added a sequence of images, bit and pieces here and there, the smaller particles, the bigger wood chunks. So all this, even sometimes they created the character because it is little complicated to place a real character in that situation. So they use CG characters. Excuse me. So all these wooden chunks are created and composited. Composited is like a layers, different layers of objects placed, and it is a miniature model placed in a real place. And also there's a DI called a digital intermediate. They do the color correction and adding so many other details. This is how the real CG scene is composited. So the boat is a real boat. All the other scenes are CG, that is computer graphics. So here, if you see this scene, big waterfall. Actually, to create the scene, they use a multi-terabyte storage. Each detail is created using CG and composited. In case of a normal human hours, if you create all these CG works, it will take 250 years to complete. That much of effort is being rendered in this scene by digital domain. Usually we call that as a shot. From one camera angle to another camera angle, we call that as a shot. For a one particular camera angle, they work a lot of details. All this rendering, like Bahubali, they did so many compositing, the mountain, the different layers of water, the smoke, all this. This is another shot from Aquaman. How the backgrounds are composited. It's all image. Simply is in a small beach or a studio where is standing near the water. The remaining things are added using a matte painting technique. It is a technique used to create backgrounds in Photoshop. So either matte painting or a 3D scene. The background, all those distance objects are matte painted. It's a painting usually done by an artist. And some of the nearby the creatures are all created in 3D. You can see the backgrounds, how they composited. Actual scene versus reality. So I'm going to show you the differences. When we are talking about 3D model, high detail versus low detail. Just a minute. I'll be I'm going to use another software called Substance Painter just to show you the mesh. We created a project for a medical industry. It is a representation of an eye. It have three different layers, like outer layer, inner layer, and the middle layer. So I'm going to show you that eye inner details. It takes some time to load. Yeah. So this is the inner detail of an eye. You can see there are so many details, and some of the details we painted. So you can see the actual mesh. All those boxes represent the mesh detail. It comes in a lac. Even we have an higher detail mesh. Eye outer shell. So it's look very simple, but if you see the mesh, you can see the details. We use this model for rendering. So basically, what is rendering? It is a simpler image. It's a simple square or box. and a plain background. But you can see so many other details, like it look like a glass. It also observe the light, reflect the surface it reflects, and the lights, there are different colors of lights and it reflects. We create image. Actually, every object has a surface. So when we are talking about a surface, so I hope you can see the plane with four corners. I actually removed some of the mesh in between, the segments in between. So actually one point is called as a vertex. It is actually represent the 3D representation of a model. When we connect two points, that is from A to B, we call that as a line. The same, when we have a 3 points, that is like a triangle, it forms a mesh. I'll show you an example. I use a create but tool, and I'm making this area a little larger. The 1 point, 2, 3, right click, it will create a surface. So here it is actually a closed, like a skin-like type of object. In case if it is only 2 points, it will create only a line, thin line. Even you go closer, it will show you only a line. But when you connect 3 points, we call this as a mesh. We call this as a tri-mesh. The same way, we add another point somewhere here, and connecting with this point, this and this, we call this as a quad mesh. Quad mesh actually contains 2 tri-meshes. So what I'm going to do is delete this part, and in this particular plane, we have 2 tri-mesh, 4 vertex point, and 1 polygon. To see the details, actually we have a statistics option in 3ds Max. I'm applying this option and can see poly, 1 poly and vertex 4. I'm using a magnifier tool. You can see the polygons, 1 polygon and 4 vertices. So more number of vertices or more number of polygons actually add weightage to your mesh. But when we are talking about rendering, we never bothered about the polygons because we need the surface details. A more accurate model have a more curved shape. Most of the CAD model, what the mechanical engineers, product designers, what they create usually comes with a lot of mesh. We actually bring the mesh, add details, and we keep lighting, camera, and then we render. Render is a process where light is being calculated. For example, where the light is, say for example, I'm deleted this object, I'm taking a sphere, I created a sphere. I want to place a light, I'm keeping a target light. I'm keeping a target light. So this light is targeted towards this direction. So what happened? These lights fall to a certain area and the light is reflected by the surface. The surface detail is important, whether it is a metal, it is observant like a matte finish, or it is a glass which will do the both reflection and refraction. Based on that, the light react to the surface. So for that calculation, we use a render engine. sometimes we call that as we use a different engine like V-Ray, I-Ray, and all the other stuff like mental ray, all those render engine to calculate the lighting, how the light fall on the surface, if it reflects, where the light bounces to, and what color it's take. Probably this one is a red in color, and I'm keeping a surface. Something like this. Then if the color is white, then if I keep the light, if it is a reflective surface, the light actually falls. This is a white light supposed to be. The light falls, and when it reflects to the surface, it will carry that red color to this area. It is refract, then even though the red color is refracted and fall on this area. So these type of calculations will be done by the render engine. So when we talk about render engine, it's actually render the scene. So this is how it will look after I set the light. See, default the object is so reflective, shiny, and only I place the light on this area, and these areas looks darker, and it will create a smooth reflection and all those stuff. This is called as rendering, where we are actually worried about the type of reflection. More reflective surface, it will take a much longer time to render. Even if it is a refractive surface, it will take even much longer time, because the calculation, the light passes through and deflect to a different directions like a prism. It will deflect, and actually all those light particles goes in a different direction and fall to a different place. So the calculations takes a much longer time. When I'm working in a Amar Prakash company, like I'm actually an architectural designer at that time. Later, I moved to an interior design company. In architectural design, sometimes a single image with a quality of 1K or 2K, it will take a render of 4-5 hours. So simply we create a model, we put render, and we have to wait for some time to see the result. Even we do the correction, we need to do the correction, we need to wait at least 4 to 5 hours. So if you have a very powerful machines like a servers, then it will reduce the time, waiting time. But still, the rendering is a tedious process. So when we talk about all this, there are some techniques. We actually isolate the floor, isolate the object, we render separate object, and we compose it together. In architectural design, we do the same. We first render the building, and then we go for the trees alone, and then the car, the people, all those stuffs we do separately. But it will at least take a very long time. I'm showing you an example. It is an high-rise apartment. So this is a apartment. This is the type of work we do. Actually, we take a CAD drawing, we create the 3D model. Sorry, just a minute. It is comes in a black and white. Okay. Okay. So initially it is a black and white. So you can see the car, the plantations, the environment, and all those glass reflections. So this is actually takes a lot of time to render. So adding colors, DA is involved, the digital intermediate, where they do the color correction, some bloom effect of lights to make it more dramatic and realistic. The flare effect. Actually, we did a similar project here in actually these are something called as interior design. But these interior designs, as I know, these are not on scale. They just want to do a better presentation. Even a 10 by 10 room will be shown with a shown like a lot of space is available, like a bigger king size bedroom bed and teapot and what is that, like a glasses, mirrors, so many things they'll add. Actually, the functional interior, which will not look something like this, we have to take care of the lighting. We need to do a light study, how the light enters into the room. Is that room is dark, lighter, and the type of paint we use. All this is comes under the functional interior. Some of these objects are not to scale, and just for visualization purpose they did it. So we did actually a similar project. I'll show you. We call that as an acrophobia. We just created an environment. Actually, the purpose is something different, but here we did a similar environment. So this is how we actually do the environment process. So actually there is no texture here. The environment is completely an image, multiple images stitched together like a panoramic image, and all this building have a low resolution texture. Actually, our use case is something called as an acrophobia, like an people who are afraid of height. So what we planned is in a VR experience, someone wearing the goggles and walk on this plank. So this is an high-rise building. We create a feel like it is an high-rise building. People walking on the plank from this corner to this corner. We have some metrics to analyze how much time they take to cross this plank, all this information. So if you keep your camera somewhere closer to this, you feel like you are in an high-rise building. Say a character standing on this area in a first-person view. If he's like looking around, definitely it feel like he's in a high-rise, standing in a high-rise building. So it's have all the cars going, vegetation around. So all this stuffs will be there. It's all completely low-res polygon modeling. The total of 64,000 polygons we used to create this thing. So when we're talking about 3D models, we use certain softwares. I like to show you a character software. I hope you see the characters, different character faces. Actually, it comes with a full body character or a face alone, just a thumbnail view. We use a new option, which is called as an Autodesk character generator. In the initial time, we are in a project where a customer gives some gender and they want some type of character like a Negro or black Indian, black American, white male, something like that. They give a preferences. This is how the characters look like. So creating a 3D character takes a lot of time with all the mesh scope, and animatable character really take a long time. You have seen that Pixar studio characters and all, which is actually they spend a lot of time, something around 6 months or a year. A team of people work for the character and all those details. But we have a very short time. Example, to create this character and to present to the client for approval is around 1 week turnaround time. So within that turnaround time, it's impossible to create a detailed character what they explained. So we come up with a solution from Autodesk called Autodesk Character Generator. So from this Autodesk Character Generator, there are different types of body shapes and people. So we used some of these premium features or standard features. We have our own license. So I just choose this default character and say customize. What will happen? It will take to the next level. So these are all web-based. So in this web-based, you can first customize your face then the color, skin color, and the eye hairstyle, and the attire, and also the body type. So all these can be customized. So here first I'm taking the face. So in case I want a lean face, not a very chubby face, then I can use this model as a reference. This is the first model I'm using on the top corner. I'm going to use another character. Say, for example, this character I'm going to use. This is called Lena. For a, this is called Sophia, or Tiffany I am using. Drag and drop this model as a reference. So what will happen? It will take a morph target between these two objects. It will create a model. So you can see there is a slight because the screen is too small to show. There is a change. For example, I'm going to use this bigger lipped character to show you a major difference. So you can see the same character with a bigger lip. Or I can play in between, something like this. Some older looking character, I can drag and drop. So you can see the wrinkled screen. So I can show the same character, how it look like when it is aged. And I have a separate control for eye, ears, mouth, chin, nose, and the cheek. So all this can be controlled. So in case you want to control the eye alone, then you can switch off this point and you can go to this option and you can choose a better object. So here I can use an eye which is much bigger in details. So you can see it is from smaller to a wider eye. Such a way I can change all these details, and then once I'm satisfied, I move to the skin. So when I move to the skin, I can choose a different skin tone. Currently, there is an indicator where it indicates this is in use. So in case I want to use another color, like a dark shade, so I can go use darkest shade. See, the skin tone is completely changed. In case I want to use the previous one, then I can switch to that previous one. Then the eye tone, I have a different types of eye. I need a blue eye. Then I can choose the blue eye. So that characterization is completely changed. Even something like this dark devil-like an eye, we can use that eye. Then the hair, we have a different types of hair. So something funky or a traditional one. To show it as a villain type of character, then you can use this funky and all these characters, hairstyles, or a little something similar to this. The side you can see it is looking a little evil character. So I can change the hairstyle. It drastically change the appearance. See, and change the eye color. It is a web interface, so you don't have to install anything. Then you can go to the body type. You want a lean type or a fat character. So whatever you want. See, this is the character actually what we have. So I want a little fat character, drag and drop those. And you can apply this keys. See, the character looks little fatter. So entirely the characterization varies. So this way I can go and add dresses. So there is a lot of dresses for female and male. So I can go for a medical representative, like medical doctor type of dress. It's a top, bottom, as well as you can choose the shoes. So this way I can create characters, and I can, once they finish with some name, and I just save this character. You can see your character in the thumbnail view. It will take some time to show your thumbnail. So this way, I can create so many characters for our project. Once you created the character, you can generate this character. Now this is in web interface with the Autodesk login with your login. So I have my own login. So these are all saved in my login. So I want to use this character for my 3D work. So I go down here. It shows the name. You want to give another name, you can give the name, and also the character height. In case of 6 feet, you can give 180 centimeter or something related to your specification. And here is the poly resolution. I am talking about LOD, level of details. So in case you are going to use this as a crowd, the mesh will be lesser. So you can choose the crowd or low resolution mesh or a medium or high. So whatever the mesh it shows blue in color, you have to pay some credit. Otherwise, you can use it as a free. This crowd and low is free, but when you go for a medium or high, this is chargeable. So apart from that, you want a quad or triangle. Sometimes for the game engines, we use triangles, but for rendering and all, we use a quad. Also the textures, we need the cloth texture, the specular map, that is the shininess, the normal map, the details we'll talk about in later sessions. So specular normal map we can use. And also there is something called as a facial expression. This facial expression actually helps us to do the facial animation. So for that, you need a bone or a blend shape. We call that as a morphing, like how we have the slider to choose the characters here in the web interface. The same way, the blend shapes have a slider to adjust, create the facial expressions. And also we have a few options like generic FBX. FBX is a format used across the gaming industry. And also the Maya file 3ds Max, or directly you can import to an engine like Unity. So I use a 3ds Max. So 3ds Max and go for a generate. Once I say generate, it will take some time. It is a cloud interface. It will take some time. And once it's generate the character, it will intimate to your logged mail ID that the character is generated. Once it is generated, you can come to the generated characters. You can see all the characters which is generated in your login. So last time I did this. So now I want to download. This is actually a 178 centimeter. I used all the crowd low, medium, and high detailed model with quad, with blend shapes, and also I chose a Maya file, 3ds file, also the generic. I am not used Unity. So I used all the shapes and pressed download. When I download, it will automatically ask where to download the file, and you can download that. That's what I shown you previously. So here is the character. I'm just importing this. Actually, it is a FBX format. It is a native 3ds Max. So I'm opening this and open this 3ds Max FBX file and press open and say OK. It will take some time to load. The FBX actually comes with animation and also the texture files. The only disadvantage with this Autodesk character generator is the cloth, everything is attached. It is a texture in a texture format. So first, this is the 3D model. It contains all the 4 characters, and you can see I'm just hiding some of these geometries. This is the bone system for our character. So rigging is a separate process where we do constraint from a start to end, so that the hand will not able to bend backward, and it will only move in the forward. The wrist can be rotated to a certain amount. So like this, we can do certain constraints and create a rig. So what we do is we unhide that. I'm not comfortable with this type of bone because there is so many points. I don't know which point to use or what to leave. So 3ds Max, I have another advantage called as a Autodesk, that biped. Biped is a two-legged character. Previously, it is called a Character Studio. It is a standalone software for Autodesk 3ds Max. So now it is integrated in or 3ds Max. So I'm going to run a small script. Actually, this is the place where, just a minute. Okay, this is actually the zip file what I downloaded from Autodesk character generator. And once I extracted it, is having all that texture files. This is the texture file for the 3D model. If I do any changes here, it will reflect in the 3D model. And also there is a script called character generator FPX to Biped. This is the script which is used. So directly drag this script, drop it into the viewport. So you can see some blink in this area. Actually, it converts all the bone into a biped. So sometimes to simplify our work, we use a script. So it converts all the bones into a biped. It will take some time. Because there are multiple characters, it takes some time. Okay, now it is completed. Now I switch off the geometry. You can see the bone structure is now usable. So I can drag this character. I can move it. These are the constraints which actually I have to do with the bones. So I need to connect all the links, where the start point, where the end point, and then I need to create a rig. So this way I create a rig, but this Autodesk character generator simplified my workflow. And this character can be used for a rendering also. So other characters are available. The reason we have another option also, like I'll show you. Not only character generator. The same way, there is another option called Mixamo. This is the product from Adobe. Either we use a character provided by Adobe for our sample projects. So there is a plenty of characters available in this site. It is for free of cost. You just need to log in. And most of the softwares, Adobe, Autodesk products, they give a evaluation version for teachers and students for a year. So if you have a proper login and your ID card, you can log into the portal and you can get a 1-year subscription. So you will get all the Autodesk 3ds Max, Maya, Motion Builder, Mudbox, and also the same way the complete suite of Adobe media and entertainment media creative cloud suite is free for you for a year. So here directly I can use the character what I created from Autodesk character generator. I can directly upload the character, or I can use any one of this character. Then I can use the animation menu and simply click and load to see the animations. So whatever the animations you see here, you can use it here with this model and check whether your model looks fine. Even when you upload a character, you can do the rig here. The automatic rig creation tool is available with Adobe Mixamo, which can be leveraged to create your own character rig. So otherwise, you can create a character with Autodesk character generator, then take it to Autodesk Motion Builder and you can create a rig. Once you create the rig, that can be used for animation in various projects, maybe for a rendering, for video graphics, or for a VFX, you can use it. And I like to show you some more details. 3D modeling, we are talking about animated movies, visual effects, motion graphics, games, and AR, VR. When we are talking about animation, character animation, creature animation, animation generalists who do props animation like moving an object, animating a car, animating the trees comes under animation generalist. Simulation, motion graphics people is otherwise called as the simulators, where they do the cloth simulation, water simulation, and all type of things. And mocap artist is a motion capture artist. Usually they capture the real-time animation from a character to a 3D model. So I think I have mocap details. Motion. Motion. Sorry. I don't have motion cap, but usually what they do is like you want to create a action of Ronaldo, then Ronaldo's they place some marker on Ronaldo's body and capture the same action and convert that as a animation and apply to a character. So this way mocap artist will do. Facial expression is another area. See, I'm just switching off all the L4 objects, bone objects. You can see the character. I have something called as a blend shape. So here is the blend shape value. I have so many expressions. See the expressions, closing or blinking an eye. So this way I can animate the character's eye, the nose alone, this is just adjusting the lip. So based on that, I can create various expressions. So to create this animation, there is a special animation artist called facial animation artist. They do all the facial animations. And when we are talking about texturing, there is a procedural texturing like creating a marble texture or a tiles character or creature texture is created by most of the time the artist like a dragon or an dinosaur skin. All those details will be created. Environment design, like I shown an environment where the buildings, walls, the windows, doors, and all those things. Game texturing is another area. I'll show you because short of time, I'm just going to explain you certain things. Game texturing, then the lighting. Lighting, it is fall under three categories. Cinematic, you can keep so many lights to illuminate your object. Studio lighting is for the product presentation, and game lighting, that is a limited amount just to lit up the environment, or sometimes you bake the light to the character and use it. So this way you can use the light. Rendering for animation is like a sequence of images you render and then finally you compose it. The same way rendering for VFX. Rendering for VFX is nothing but you have a different layers of animation, like I shown a plane and a ball. They first render plane one image and the movement of the ball, multiple image, and compose it together. So if it is an 100 frames, then they use 101 image. One is a plane image, that is the still image, and the ball rolling animation, that is 100 images. Otherwise, you have to render both the images 100 times, that is 200 frames you have to compose it. So in order to save time, what they do in rendering in VFX, they take it as a plate. That is like a layer. The first plate, the background plate, the mid plate, explosion plates. So something like that, you can take different plates and compose it together. When it comes to real-time visualization using game engine, we leverage the usage of CPU and a GPU. So in rendering and animation, it's all calculated and basically your hardware. It is actually depends on your order, like CPU, that is a processor or the RAM. But when it comes to a game engine, the output is either you view in mobile or web-based WebGL or like HMD devices like Vive, Oculus, something like that. So it's have a limited capability. As I already told, every vertex will be calculated in the 3D engine 60 frames per second. So there is a lot of calculations involved by the 3D engine. So when you move an object from one place to another place, or you are moving from one place to another place, every time the 3D engine redraw the lines by acquiring the new targets. So that's why the CPU is so working, it is having a heavy load. In order to reduce that, what we do is we create a low polygon model and put all the efforts to the GPU, that is the graphical processing unit. So it will take in terms of textures and play smooth. Most of the games in nowadays comes with the GPU capability. So I'll show you a small example how we use the high polygon to low polygon model. Okay, I actually created this presentation for this. We have a mesh baking option, sphere divided. Actually, this is a small example. I saw this example. This is what the image I came across in the internet. So I plan to create a similar type of effect. In order to create this effect, what I did, I created a sphere. Actually, this is a sphere and a geosphere. I created a sphere. You can see it's have a quad mesh. So I need to divide this in a triangular way, or like a diamond shape, which is little complicated for me. So what I did is I already have something called as a geosphere, which is already in a triangular shape. So I created a base triangular shape. Here I have a duplicate object. So this is a basic geosphere. After I created this geosphere, what I did, just a second, I just going for statistics. Okay, so this geosphere is 1280 polygons, just a normal geosphere, and this sphere is actually 528 polygons. So this is like 50% of the geosphere. The sphere is 50% of the geosphere. Geosphere have more mesh. And I want some details, that is a depth in between, because it is not, when I remove, I'm just not showing this mesh, you see it is look similar to sphere. I want something like this. So what I did is I selected all this vertex. I'm converting it to a editable poly edge mode, that is I'm selecting the lines one by one. So all these edges I'm selecting. So this way, Control A, I selected all the edges. Then I go for a chamfer tool. Here are the values. So I created a space, something similar to this. So I already created this. I don't need this one just for a representation. So I created that one and also applied some depth in this. So first one, what I did is I created the mesh, and now this is 8,960 polygons. That is like 8 times comparing to the geosphere. After did this, what I did, I selected only the in-between area. So it is difficult for me to select all this area. So what I did is I just selected the major faces. It's take long time. So what I did is I created a selection. So the full selection looks similar to this. Only I gives this gap, and then I applied a extrude modifier. So this extrude modifier actually extrude the surface. I'm giving the value. Either it is in a negative or a positive value. So this way, what my intention is to create a positive value. So what I did is I created this object. So I can come out of this, and now if I show you, this is a 12,800 polygons. That is the 10 time of the geosphere. 10 times it is being increased, and you can see all the details. I got it here now. But 12,800 polygons is too heavy for my 3D engine. So what I did is I want to transfer all these details to my 528 polygons. So what I did, already there is an object inside. Just it has to be in the same place. So I just created a overlapped sphere on that place and apply a UVW map. Unwrapping, we call that as a unwrapping. So UVW map, I apply a spherical, because the surface is a spherical surface, so I applied a spherical surface and taken that as an output. So I given a name called detailed mesh, file, export selected object. I don't want the entire object, I just want only the selected object. I say export selected, and in the presentation material folder, I just go for a mesh baking. I have already a detailed mesh FBX. Just select and overlap. So now the detailed mesh is ready. Then what I'm doing is I'm going to create a low polygon model that is unwrapped, properly unwrapped. Again, the same process, export selector, and go for a low poly mesh. I took two different high detail and a low poly mesh from 3ds Max. Now what I'm going to do is I'm going to take the Substance Painter. Substance Painter is a software. It is used as a 2.5D texturing software. So it will give details like embossed effect and all easily. So what I'm going to do is for a new, I'm selecting the low mesh. First, the low polygon mesh, that is 520 polygons. I'm taking it open. And I'm leaving some of this settings normal. Here the document resolution is 1024 and I can go up to 4K resolution. This is actually in a 1K resolution 1024. And already it is UV unwrapped. So I don't want the UV template. So I say okay. Discard the word file. I say discard. I don't want to save. So this is my 3D model. It is simple. Some edges are visible, but from the long distance, you will not see that circular. So there is some trade-off while using the game modeling. There is you can see the rough edges. So in this, you can see the model comes as a tri-mesh. What I do is I go to the texture set. That is a baked mesh maps. In this dialog, I'm just using the high definition mesh. Select this mesh and say detailed mesh, which is a 12,800 polygons. I choose this detailed mesh and say open. Then the projection, how I'm going to project to the surface. Maybe it is the intended low poly model is a smaller one or bigger one. But anyway, it has to be from the surface is 0.05, some default value what I use. And also some resolutions of aliasing where I give 8 by 8. And once this is all over, base selected texture. I am also remove this world space normal. So I don't want this world space normal. Sorry, ID I don't need, world space normal. And bake selected texture. It takes some time to do the process. It will take all the normal and the other details and textures. Now what happened? The high poly details is transferred to the low polygon. You can see. But still, this is a 520 polygons, but 12,800 polygons detail is being transferred to this mesh. So now I'm going to the layers and I want the pure iron material. I can apply. So instantly it's look like a iron material. So there is a smart materials and also some materials. I'm using a granite option. Okay, so in smart materials, I have a granite. So marble option, I just drag and drop and remove this iron and a new layer. So here is the model with the dip. But still, this is look flat. But due to this normal map, here is the normal map. So just delete the normal map, it looks flat. See? This is how we work with the low polygon model. For example, sometimes we use an high resolution mesh. I just close this one. I'm using ZBrush. ZBrush is used to create 3D models, also used to sculpt 3D models. Say 3ds Max, Maya, it's have a limitation. After a certain polygons, for example, 10 lakhs polygons or 20 lakhs polygons, it's tend to rotate or transforming is a little difficult. So even navigating inside the window is difficult. So what we actually do to add details is we take the model to ZBrush and then we do the detailing. So for example, here I'm having a load tool option. So this is a human anatomy. Take some time to load. So once this is loaded, so you can see a detailed sculpted human model. So it actually contains millions of polygons. Just a minute. So you can see there is a lot of details sculpted in this model. We cannot take directly this model to 3D engines like Unity or Unreal. So what we do is we finally do this sculpting, take it to again 3ds Max or Maya, then create a low poly model and transfer it to ZBrush, sorry, Substance Painter. Then from low to high polygon, we do the same process and transfer all this to the detail to the 3D low polygon 3D model. So this is where we use ZBrush. Rendering, so GPU and CPU, once this is taken, will take all the material details and we apply it to the 3D engine. So the 3D modeling pipeline is basically we use basic references and details. First, once we get the scene, what we do is, get the project, we list out all the assets. So if this is going to be my scene, first we list out the assets. What are the products we need to create? From a small details to a large details, we categorized by a level, like leaves or a complicated statue. Everything is listed in an Excel sheet or somewhere, and we categorized the details. Once these details are categorized, what we do is we take a basic reference and details from the web or from the client. Once this is over, we do the low polygon model first. Sometimes the client will provide an high polygon model. In that case, we create a low polygon based on that high polygon. We call that as a topology or creating the high to low detail. So once from the scratch, when we create a low polygon model, we save and then we apply a details to that. That is called high detailed modeling. Once the high detailed modeling is applied in a 3ds Max, then we move to ZBrush or Mudbox and give more details to the model. Then we comes to an unwrapping. Unwrapping is something like we are creating in the layer for the texturing process. So in the sculpt, one second, I'll just open. So this is actually, we did it for a client. And here, this is the unwrapping thing. So this is the 3D model. These are the surfaces, the side, the front, whatever the details we want extract, we extract it from the model. And this is where we do all the paintings. So this is also baked the same way. This is a very low polygon object, and then applied the texture, the colors and all the details in this layer. So if you see the trim lines, actually all this trim line, we do the model, it will take a very long time. So what we do is we create it here in the scene. So some of these are hidden. So like a logo, layers of these details. So I want some details here. So all this will be added using this UVW. It is like a wrapping of the texture. How we are going to wrap up the texture. The texturing process, again, we use Substance Painter or Body Painter software to create a texture. Then export to compatible formats. If it is a VFX, we do render. And in case it is a engine, what we do is we export it into a different format. For example, in one of our projects, we exported to FBX format, but later we come to know there is a glitch. So there is a slight movement in the object. Whenever we see it in a mobile, there is a small movement in the object, which we don't need. But we tried a lot. Still, it is a problem with the FBX. Later, we find out in the forum. Then we use a Collado file format that is called DAE. There is Autodesk Collado and there is an original Collado. We used Autodesk Collado and it's not worked out. Then we went into forum and find out there is a Collado file, native Collado file, which is used to transfer the details. So after transferring the details, we found out that it is stable and it's good. So the exporting to compatible formats is very important. Then the integration, we integrate in Unity or compositing software. And sometimes we do lighting in 3ds Max or a 3D modeling software. They are sometimes in the Unity engine. Then we do the packaging. I have other works also. So I have an. I speak just to imitate the Pirates of the Caribbean, where I created 2 layers and sculpted using a 3ds Max sculpting tool. So the total polygons in this is around 20,000 polygon. So this is around 10,000 polygon and this is around 10,000 polygon. Just to create that visual, I created this, and then substance. I took it into the substance. And this is the texturing I applied. It is a very rough texturing what I did yesterday, like a rock and a snow one with the background environment. So this is how in movies they use. It is a very smaller object, but nearer to camera, it looks larger. And due to running out of time, I'll just show you something in Substance Alchemist. Substance Alchemist is a 3D authoring tool which comes with AI, artificial intelligence. So sometimes creating textures is difficult using a normal one, like depth and all. So what we use is Substance Alchemist. So this is a user interface of Substance Alchemist. So I want a mesh parameter, either I want a cube plane or rounded cylinder or a sphere. So I go for a plane. So here default there is some object like mud. So these are the layers. So directly I can drag and drop the mud. You can see I created a mud, and in the shader option, I'm applying a displacement amplitude. You can see real-time displacement. Depth. Later what I do is I add a layer of water. You can see the water layer on the surface. For static, you cannot animate these layers. You have limited options. So this is the water level. Here I have an option like water level. Either it's look drained or little wet. So I can imitate. This is how in game engines they create textures. So it is completely submerged or a little, and also the wetness. Here you can see there is a wetness. Usually when the water presence, it shows the wetness, but in case you want a dry one, you can do that also. Edge wetness is nothing but the edges, how it's get wet. For example, like seashore area, when the waves comes in, you can see the wet. So that type of wetness you want to add, then you can use the edge wetness. So from the water, how much distance you want to add this edge wetness, or water at darkness, and also the flooded level. So all this can be done. And also I'm going for a new project, some name I'm giving, and created this. What I do is I create, I'm just Googling some images. In a live demo, just checking. I just forgot where I kept the details. Speaking Alchemist. So I just Google this wooden block image. It's a simple image. That's it. It is a JPEG image. What I do is drag and drop it into your Alchemist. It will automatically detect and ask you a few questions. It is a multi-angle material. Sometimes we create a material using a photogrammetry option. Here I'm using image to material. It is AI powered, or texture import. You can take multiple images and import and create a texture. So either multi-angle or a texture import or image to material is an option. Use bitmap is a regular one. I'm going to use the image to material with AI powered and say, okay. So immediately it will do a process and create a material with all the depth. The artificial intelligence built in with Alchemist understand the depth details and create a material based on that block. So this you can directly apply to the wooden object like a cylinder and show it like a wooden block. It takes some time, and I just removed that. Base material. This is the wooden box we applied, and this is the image to material. And actually, the displacement amplitude is too high, so I just reduced the displacement amplitude in the settings, and you can see the same image that tiled, there is a little different which can be adjusted, and also you can see the depth detail in the image. Just one single image I can create texture. So variety of users, like whatever I create here, I can save here and use it in Substance Painter or directly into the Unity 3D engine. So this is how actually they do painting. There are two different materials like masking in Photoshop. So here there is already a texture on top. If you want a cement like texture, you do it using a Substance Painter or Alchemist. The same way, some artifacts can be added, like a clear metal and a rusted metal, or a water in a mud. So all these things are easy to do. Otherwise, you have to do the base model and do all the details in ZBrush, then come back to Substance Painter, do all the baking. It takes a long time. So this is your work. So I quickly go through some of the other details. When we are talking about the Unity walkthrough interactive architecture, so this is how nowadays they use the interactive architectures where architecture models exported. You can see that water it's created using Alchemist and created a very base model and shows how your flow plan looks like in the architectural sense. And people can walk in and rotate and see in real time. In a walkthrough or image, you will not get this option. So anywhere you can go and see all the details. Sorry, already we have seen this. And rendering technique. Photogrammetry is another technique used in the industry. I'm just opening this with 3D modeling, either the traditional way they do it from the box, or they nowadays use the photogrammetry, reality capture. So where they use multiple camera in multiple angles and capture simultaneously, and using Recap Pro from Autodesk or any other software, we stitch all the images together and create a mesh. It is something similar to creating a panoramic image, but here we create a 3D model. So you see all the dots are actually the camera placements. So we capture the details, something like this, and also some actions can be captured. All these images from the camera, all the images will be captured, stitched together, and created some pixel meshes and attached together. So just that 1 second that they will capture all that images. It's a huge rig and expensive rig. So often people will not use this rig, but for some sophisticated details, they use this one. And again, the photogrammetry, like a good lighting is important. And here, using your mobile, we can create a 3D model. So from multiple angles, you have to take the image. Usually, people take 600 to 700 images in a different angle, front, back, top, everywhere, and stitch all this image together creates a masterpiece. But sometimes even a lesser image of 30, 40 images also will do. But still, more images are recommended for finer details. So you can see he imported all the images to the software and create a point cloud and see the details. Then these details will be taken to ZBrush or other softwares and do the cleanups, and taking it to 3D softwares for creating a low polygon model. The advantage is here it comes with all the texture. So once you create the low polygon model and taking these details to Substance Painter and baking and applying the textures will give you a realistic 3D model. This technique is called as a photogrammetry. Terminator, actually digital domain created this Terminator dark phoenix model. Some of these are impossible. So something similar to this is impossible. They created some 3D models, faces and all exactly the same. See, this is how they created the models and composited together. So it comes under visual effects. For visual effects, they never bothered about the meshes. Model optimization is another area, say something similar to this dustbin, which is like there is a lot of volts. Creating this will create a huge mesh. Again, we do a technique using a Substance Painter. So I have a small example for that, which we created for a client. So just I'll be finishing it in a few minutes. So
okay.
yeah, server rack. I know it's already late. Just give me a few minutes. So this is actually a server rack we created for a client. So some of these details, actually, you will not believe. See the model, the details. There is a fan, the USB port. There are so many things. Definitely, it will take a huge mesh. But using Substance Painter, we created this entire model around 24 polygons. So I just show you a few options. Sorry, all these details. These are all the details. This front bezel. This is actually the front bezel, which took a lot of polygon. This is actually a one polygon. This is one polygon, four-sided object, front and back. This front is a one polygon, and the back is another polygon. And this complete box is a actually it's a six polygons totally. It's a box actually. If you see the mesh, you come to know it is a tri mesh. Actually, it is very fine. This is one tri and this is another tri, and the same way here this is one tri mesh. So it is a one simple box. We given all the opacity details the same way that a trash can be created. Here we have given so many other details in the cover. So it is actually tremendously reduced the weightage. So maybe sometime the optimization, model optimization is something like this. We use two different objects, but this inner portion is unnecessary because we are just going to show the outer part. So we'll remove the faces. These are called as optimization. But most of the 3D model artists, what they do is they keep all this object and give output to the 3D engine, which is not necessary at all. So this is how the high detail model converted to a low detail model. Some of the reference images. This is another image with a complete high detail and a low detail. So it's easy to bake all the details. Even we take this model to ZBrush and do the changes. The same way, low, medium, and high polygon meshes. Material design, it is another aspect. And this is how they created a IV texture, like a real life texture. Say this is a leaves texture used in Unity 3D engine. This is how they capture the multiple images, something like a photogrammetry or material creation option, and take it to Photoshop and did some correction, and material authoring tool like Substance Designer is used to create the texture and the bump details, and the plane is placed all over the place, and the final result will be this. So I'm closing my session. Thanks for the time. Sorry, I took some more time. In case you have any doubt or you want to add anything, you can note down my mail ID and contact number. So you can send your queries or details. Sir, that's it. So,
yeah. Okay, sir. Thank you. Thank you so much.
Thank you. Thank you.
Just a minute, sir.
Yeah.
Thank you, sir. Participants,
Thank
if you have any queries, kindly post it in chat box.
Yeah, Praveen Kumar is asked about the software we used. Actually, we used 3ds Max, but the workflow, the pipeline is all similar. Like you can use Blender, Maya, anything. It's the same. You do the same type of process like modeling, texturing, rigging, animation, all that are similar to all these softwares. So what I used is 3ds Max here. And again, I just reminding you, all this the Blender software is a open source. You can download and use without any license. Autodesk software like 3ds Max, Maya, Motion Builder, all are comes with a 1 year trial for students and also the for the faculties. So you can use your valid mail ID and ID card to get that license. You can if you are reading about Mandar Sumant. Actually, there is another software, but I'm not discussed here. It is a plugin used to from a face to photograph. There is an avatar creation tools. I used something called as Autodesk character generator, but there is a illusion character generator is used. They also have avatar creator options where you can just simply post your photo. It will create a 3D character, just like you. I hope I addressed your question, Mandarsman. And there is another question from Mandarsman. Sir, what should be the configuration needed for CPU for it? Say, usually I work with an Intel i7 processor, 9th gen, with 16 GB RAM, and the main thing is the graphics card. I use a GTX 1080. It is a Alienware system what I use, but in case you are using assembled system, I prefer i7 10th gen with 32 GB RAM and also a good graphics card of 4 GB or 8 GB. And in case it is a studio type of environment, I prefer using a server. So with a lot of RAM is needed to do this type of work. And also for rendering, in case you are focusing on the rendering side, you can prefer Xeon processor. It is a silent processor with a lot of efficiency comparing to i7. i7 tend to eat a lot. So if you have a good cooling solution, then definitely you can go for i7, or else I can prefer Xeon for a rendering based solution.
Thank you, sir, for describing the various AR VR tools and techniques to render the animation. And we feel like it will be useful for faculties. And we are once again welcome you for valuable inputs, sir.
Okay.
Participants, you can join the next session by 11:35 p.m. So 11:35 a.m. the same meet.
Thank you.
Thank you, sir. Thank you so much.
Thank you.